All right, this is lesson 33-3, spheres and solids of rotation. So we'll start off with the sphere. Um, it is this. This is a sphere. It says he provides spherical paper lanterns to his customers. Um, a sphere is a set of all points in space that are a given distance, which is called the radius, from a given point. How is that definition different from a circle? A circle is a set of all points in a plane. So, very, very similar. So, we have to have a center, and every point that's located the same distance away from that center, and that distance is a radius, will help us locate the sphere. So, it says consider the cross sections of a sphere. Well, um, describe the shape and size of the cross sections. Well, I have a GeoGebra page. So here is the green plane represents the cross section, and this is what the cross section would look like if you opened it up. You can move it out. You see, you have a circle. Move it all the way through. You have circles. We can change the tilt of the plane and rotate it in and out. And we can turn the plane around a little bit. Still move it up and down. Okay. Tilt it. Okay, it's completely left. Rotate it up and down. There's it's right up there. So anyway, you see that it doesn't matter what I do to the cross section. The cross section stays a circle. So the only thing that changes is the size of the circle. And the size of the circle depends on how close I am to the center of the circle. So when was it the biggest? Looks like it's getting smaller again. So it looks like it's the biggest when it's closer to the middle, right? Okay, so let's go back. It says describe the shape and size of the cross sections. So they're all circles. And you might want to describe here that the bigger, closer to the circle, closer to the center. The closer your plane is to the center of the sphere, the bigger the cross-section circle is. Where will the largest these cross-sections be? Through the center. Where is the center of the largest possible cross-section of the sphere located? Okay, so where is the center of the largest possible cross-section of a sphere located in relation to the sphere? Oh, the center of the cross-section will be at the center of this thing right here. So the centers will coincide. I don't know which way to spell it. Okay, so it says this figure shown is a sphere. Write a definition of a chord. It's the same for a sphere as it is for a circle. The endpoints of a chord have to lie on the sphere. Now, okay, so that's a chord, but those are both chords. I'm trying to draw them on it's just that the surface of the sphere is hard. I mean, if I'm on the surface of the sphere out here, I can go up to, any other surface on the sphere. But draw and label a chord in the diagram. Okay, so those are all chords. Write the definition of a diameter. A diameter has to have its endpoints on the sphere, and it must pass through the center of the sphere. So same as it is for a circle. Has endpoints on the endpoints on the sphere, and it must pass through the center of the sphere. Write definition for a tangent line, or it could be a plane. So a tangent is going to be a line that intersects the sphere in exactly one point. So there is an example of a tangent line. Yes, mine's not drawn all that great, but you can just imagine. Let's see, I can probably try a little different one. Here's the point of tangency. Not that much better. So there's the point of tangency. Draw and label a line, tangent line, and a tangent plane. So a tangent plane would look something like that. It's just going, it's like, imagine a piece of paper sitting on top of a basketball. It's just going to touch it at one point as long as the paper is stiff enough to stand out. What must be true about a plane that is tangent to a sphere and the radius? Oh, it's the same. So you go draw a radius to the point of tangency, you got perpendicular right there. Same thing with this one. You draw a radius to that point of tangency, and the radius will be perpendicular to that plane or to that tangent, either one. And now we go to rotations. So this is telling us, okay, so we have this thing, it's a half sphere right here, and we're going to rotate it around that dotted line, and we're going to imagine that as we rotate it, it leaves a trail. Okay, it becomes a solid. So we've done rotations before, and in the rotations that we did before, this pre-image right here would move. It would leave. It would no longer be there. But as you can see right here, we've imagined that we've rotated it around, and when we've got finished, we have actually here a sphere. I know it's kind of hard to see on a flat piece of paper, so I found a video that does a pretty good job. It doesn't have any volume, but here we've got a triangle being rotated, we've got a trapezoid being rotated, we've got a rectangle being rotated, and we've got a half circle being rotated. And they're going to just change the view of it so that you can see. And as it rotates, it leaves an image there so that you can see that when it's finished, we have a solid. Okay, so this is just, giving you something to look at. You can change a lot of the dimensions. So when this triangle is rotated, it becomes a cone. When the rectangle is rotated, it becomes a cylinder. When this half circle is rotated, it becomes a sphere. I don't know what he's doing here. Changing something. And now he's just going to redo it. This trapezoid becomes, oh gosh, I don't even know what shape that is. It's like that problem that we worked before where we had a cone and then we chopped the top of it off. So that's kind of a truncated cone is what he calls it. So he's changing, all the sizes so that you can see. But anyway, you get the point, I think. Okay, so we're back here, and so that's how that creates a sphere. This is called a solid of rotation. So here we have a rectangle, and we're going to spin it around that line, so we understand that they want us to show what that would look like. So this would rotate out here, and this one would rotate back there. And what we would end up with after the rotation would be this cylinder. And this right here is the radius. This right here is the radius. And all the way across, of course, would be the diameter. And that's because you've got something on both sides. If you only had it on one side like this one up here, then we had the radius right here. This was the radius. Okay. And let's see, model it, sketch it, name the solid. We said it was a cylinder. It was a right cylinder. And let's see, we're going to sketch and name the solid generated. Well, it's a triangle, so it shouldn't be any different than the triangles that we saw on the video, but we're rotating it about the x-axis. So we're rotating it this way, okay? So we're going to have one down here, and we're going to have one out here. So when we get finished, we should have something like this. That is quite possibly the most horrible cone I've ever drawn. But I hope you get a little bit of the picture anyway. Okay, so there's the cone right there. Okay, we're gonna do, this one says if you rotate this one, this will be what you get. Describe how figure B was created from figure A, then name the various three dimensionals. Well, it looks like I've got a cone up here. This is a cone. This is a cylinder. And this looks like I have another cone down here. And notice that we started off with a triangle, and the triangle is what became a cone. We have a rectangle, and that's what became the cylinder, and then we had another triangle down here, and that's what became the cone. So they're pretty consistent about what they become when you rotate them. It says, hey, take a wooden stick or something and attach something to it and run it vertically in your hands and see what kind of shape that you get. So since you can't do it with a partner, I'm going to show you what I did. I took a triangle and I taped it on the end of a pen. Just roll it like this, okay, and or maybe roll it up there where you can't see that good. So you get the idea. You spin it and you should be able to see what kind of path it leaves. Right about that on this part right here. Sketch the three-dimensional figure formed by your model. So mine was, this is hard to do. Mine looked something like that. And it had, I don't know how to do it. But anyway, describe other tools that you could use to create a solid rotation. I remember these party decorations that my mom had one time. When it was laid flat, it looked like a girl with half a skirt on, and then you opened the thing up, and it was a paper ball, and her skirt became full. So it's kind of like a sphere by the time you got finished. No, it was really more like a cone because she stood up on the table. She was like the centerpiece. Okay, so that gets you through to the answers. So go ahead and do the check your understanding and lesson 33 practice. And we'll check our answers here in the next